This problem gives us the graph of a cost function to produce x items, and it tells us that the function is a third-degree polynomial. So part A asks for at which value of x is c prime of x, the derivative, the smallest. So if we think about the derivative as it relates to the graph, the derivative is the slope or the rate of change in the function. So asking the question, where is the derivative the smallest, is asking where is the slope at its least value. So throughout the entirety of this interval, it looks like the slope is positive. However, right about x equals 5 is where it seems to reach close to a 0. Perhaps not perfectly flat, but certainly the least steep. So the answer to part A should be at the x value of 5, the derivative is the smallest. Now part B is a little tricky. It assumes that we understand that a third-degree polynomial will be symmetrical with respect to an inflection point. Now, it doesn't really make it obvious that this is an inflection point, so this might not even really be a fair question. But if we're to assume that at x equals 5, the function moves from being concave down to concave up, then we can treat x equals 5 as the x value with which the inflection point occurs. So when it says, for what other point on the curve is the slope of the tangent line the same as the slope of the line, a tangent line at x equals 8? Well, if the inflection point occurs at x equals 5, then the slope 3 units to the right should be the same as the slope 3 units to the left. So again, 5 plus 3 being 8, if we subtract 3 from 5, we'll get 2. So it should be true that at x equals 2, the slope is the same as at x equals 5, or x equals 8, sorry. And that's the problem. Perhaps not the best question. I think they maybe should make it more apparent that we're dealing with an inflection point here at x equals 5. It also could be perhaps a little tricky to read that graph. So I wouldn't put too much concern into this problem, but those are the answers. Thanks for the question. Take care. Bye.